Hello, hello, hello. Welcome back, guys. Today is Thursday, I believe, the 9th of July. Yes, it is Thursday. Honestly, you'd think after all this time I would check before starting, but no. Welcome, welcome on a hot, hot, hot day. Too hot. Don't like it. Don't want to do this, but fine. We gotta muddle through. Gotta keep them brains active. And today I'm gonna be doing a bunch of ESAT speed training, and I'm seeing a spike of 6 people already in the chat. Oh, okay. Oh, it's gonna be one of those days. I see. I love that for me, 6 is like a huge number that I get super excited for. As always, guys, since you're here, if you want to stick things in chat, I'm always happy to sort of deviate and reply to it. But yeah, so today is ESAT speed training day. So I know I did like a huge deep dive on the specification last time, going through all the things conceptually you need to know. But the number one thing people ask me is how you develop your speed, because the ESAT is just so fast, so fast. And the story I always tell is that I was very, very lucky that from the age of 10, my primary school had like an accelerated math program, which they put me in. And we had this really fantastic math teacher who would make us do what she called turbo quizzes, where at the age of like 10, 11 years old, it was our job to take fractions, simplify them, and convert them to a decimal. We had 5 of them to do, and the test was 1 minute long. So she'd give us this tiny little strip of paper, and we'd have a minute. We'd like race, 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 race. And that really got me in the habit early of like, ooh, let me see if I can like push my speed skills here. And so I really got the taste for it at a very young age, which means I was developing it the whole way through my academic sort of like career. So luckily, by the time I mean, I didn't have the ESAT, but if the ESAT had been a thing for me, that speed muscle would have been there because I've been developing it this whole time. So if that's something you're not used to, don't worry. Most people don't have it. Most people haven't been exposed to that. It is just a trainable muscle. And that's really what I want to focus on today. So how do you train that muscle? Well, first things first, you got to really focus on what you're doing. So if you're going to develop your speed skills, you need to make sure that the math or the physics that you're doing is that well within your comfort zone. Because as soon as you're having to think about, oh, how do I actually do this question? That's when your focus goes onto that and not onto like how everything is fitting together. So keep the math really simple, short bursts like that, simplifying fractions, converting to decimals, sprint work. Do a little rep of like 1 minute as fast as you can. See how it feels. What you'll likely find is that going very, very quickly, you'll make mistakes that you wouldn't make when going at a normal speed. You'll make these little execution errors. That doesn't mean you're stupid. Like you understand not to do those things. But that's very helpful diagnostically because it means that you see when the stress comes, what's going to break first. And so it says like, okay, under normal conditions, I'm really confident on this skill. But when you make me go at race pace, it kind of falls down. It's not as secure as I'd like it to be. Why don't I do some deep dive on that? And from there, you can find exercises in the textbook, or you can find worksheets online that'll allow you to isolate that skill and work on that and work on it and work on it until you really know every step of it. And then you have complete confidence that you can do it without thinking at speed. So today I want to do some fun challenge stuff because I think, especially given that the Math 1 content is largely based on the GCSE math syllabus and the Math 2 content is largely based on the AS level syllabus, I'm going to do like a thing where we speed run tests and then we can like have a little challenge like in here or in the Discord server. You can like post your best times, like make it a sort of friendly competition. Like, well, I mean, for those of you who like it, you know, but see if you can beat my time, things like that. There are going to have to be some caveats. So I know in the GCSE math, there are some questions that involve like drawing graphs or drawing a histogram and interpreting. I'll see in the moment whether I think that's worth it in terms of the speed. It might be because it's like a lot of small steps you have to do, and that's a particular part of that muscle. But if there's certain things that are like constructions, I'll just skip those. So you'll have to exercise some judgment on what can be done. I think as well, I've got a calculator on standby for the AS paper because there are certain things like sine of 37, like you'll just never be expected to do that in the real thing. But on the whole, I wanted to sort of show you like what you can be doing on your end. Also, let's think about this. AS papers, GCSE papers, they go back so far. And it's what the ESAT spec is based on. So you can burn through those papers all of July, all of August, without burning through any of the useful NSAA or ENGA papers you're going to use to prep for the real ESAT. So I think having that in parallel with like the PAT tests or things like that are sort of pushing your physics and math at the front end, having this parallel stream where you're doing comfortable math and physics as fast as possible is the way to then get there for the ESAT. So with that in mind, I'm going to stick you guys over here. I've got my papers lined up with their mark schemes. And let's see if I make any mistakes going at sprint pace that I wouldn't make normally. I'm going to try as much as possible to give commentary. You'll sense as well, like I kind of do these gear shifts. When I'm super, super comfortable with what I'm doing, I just go for it. But when I can tell that something's going to go a bit sticky, I kind of go down a gear, I slow down, I take it more step by step, and then I speed up again once I'm through that patch. So just look at all the different things my brain does to try and get through a paper as accurately as possible, as quickly as possible. So I'm gonna set a timer just so I know exactly how long this takes. So getting that ready, stopwatch, cool. I'm toying with the idea of like not showing the working on the non-calculator. I might do that in future runs where I like put my hands on my head and do it just like entirely sort of mental math. That would be a fun challenge. But I think today I'm just going to do a bog standard run, write what I need to, bearing in mind that it will actually slow me down. Let me get it shared. And I am so curious to see how this goes. Okay, so this is non-calc, which is important because obviously so is the real thing. Okay, get in the zone. It's really hard to do when it's hot as well. When it's really hot like this, it does genuinely fry your brain. I'm going to try and give commentary as well, but I'm going to try. You'll see me. I'll probably even accelerate through as you see me really find my gear. But I want to sort of like show how this works and see how you guys take to it. So, ready and begin. Oh, no. All right, so I'm going to call that 8184 over 12, multiply top and bottom by 10, divide by 2, 4092 over 6. Is that divisible by 3? Yes, it is. 1, 3, 6, 4 over 2, 6, 8, 2, done. Probabilities, right. So 1 minus all of this, that's 0.3, 0.6, 0.7, so there's 0.3 in total. Probability are the same, so 0.15, 0.15. Rolls it 500 times, assuming right, work out an estimate for the number of times landing on 2 would be 0.15, which is 3 over 20 times the 500, cancels. 3 times 25 is 75, done. Karim is wrong. The probability that the dice will land on 2 is greater than the probability. How does it affect the answer? The answer should be bigger. Bigger than, I'll just say it should be bigger than 75. Okay, so this, 6, so that's 7 over 2 minus 7 over 6. So that's 21 over 6 minus 7 over 6 is 14 over 6 is 7 over 3. Mixed number, that's 2 1/3. Show that that is true, right? That's 21 over 4. Keep, change, flip. So that's times. Now that would have been 7 over 3. So that's going to be 3 over 7. Cancels, cancels, makes that 3, makes that 9 over 4, makes that 2 1/4. Done. Right, so here, parallelogram. Find an expression in terms of E for the size of CAD. That's this angle here in terms of E. Z angles, that's parallel, that's parallel. So Z angles means that's E, which means this angle here is going to be 180 minus 4E. Nice and done there. Give reasonings, I did that out loud, that's fine. That many miles at an average speed of this many miles per hour. Estimate for the time taken. Well, that's going to be 4.96 divided by the 30.4. Work out an estimate. So that's going to be approximately 5 over 30, which is 1 over 6, which is hours. So that's 10 minutes. Done. Is it an overestimate and underestimate? Well, this, I made that go up and I made this go down. So that will make it go higher than it should be. So it's an overestimate. Okay. Pentagon. So the sum of the angles is 180 times 3 is 540. So angle B is 155. Angle A equals angle C. So I'll call that A. D is, in fact, I'll call that C, and I'll call that C as well. So D is 3 times the size. So that's 3C. That's C. That's C. E is twice the size of C. So 5, 6, 7. 7C plus 155 equals 540. 7C is, oh God. Interesting that that's my issue. Why is that my issue? Okay, so this is where, again, you would look at that, you would say, this is what falls, this is what's a little bit more insecure at speed. 385, but then dividing that through is 55. So C is 55, which means that A is 55. Okay, so here, volume of water at time t, what does the gradient of this graph represent? It represents the change in volume per second. So it's the rate of decrease of the volume in a tank, rate of decrease of rate of flow out of tank. So it might have been worth skipping that just because it was writing only, but whatever. So here, face in contact with the floor has a width of 2. Pressure on the floor is that due to the prism. So that is, so that's 2 solid triangular prism. Work out the length. Okay, so the force exerted, so pressure equals force over area. So the pressure equals the force, which is 720 over the area. So the area is 720 over 80. Knock that off. It's just 9. So that is a rectangle. And so it's going to be 4.5 is the length of the prism to give you an area of 9. Cumulative frequency graph. Information about the marks that 60 students got in a test. Highest was 74. Yeah, lowest was 8. Draw a box plot. Okay, no, I can't actually do this. So 60, median is there. Median is 34. So median is 34, and I'm going to draw that line there. 45 brings me to 42. So that's the upper quartile. 15 brings me to 25. That is the lower quartile. That is my box. Lowest was 8, so I'll put that there. 74 is here. Okay. Ooh, something in the Discord. These are at Excel. These are both at Excel, the boards. So pass mark for the test was 40. Sean says 30% of the 60 students passed the test. Is she correct? So the pass mark was 40. So if you go to 40, that means that 42 people failed out of 60. God damn, work harder. Sorry, that was judgmental. 30% passed. Well, 18 passed. And 30% of 60 is 18, so yes. 0.3 times 60 is 18, and that's correct. Work out this thing. Well, that's 5 times 2 is 10. Work out this thing. Well, that's a half cubed is an eighth. So Kate was asked to factorize this. The sum of A and B must be 6. Wrong. So A plus B is equal to 5, and A times B is equal to 6, as we know. Factorize fully that thing. We can take a 2, make it m squared minus 1, difference of 2 squares, m plus 1, m minus 1. Cool. Factorize this thing fully. You do this pairwise, so we have an x into a plus b. We can have a minus y into a plus b. So it's a plus b into x minus y. Okay, so here, 3 solid spheres, volume of that. This is a volume of that, 3 solid spheres. So they're mathematically similar. That's what I'm seeing immediately. So for A to B, I'm seeing length, area, volume. If the volume is 64 to 125, that means the length ratio is 4 to 5, and the area would be 16 to 25. So the radius of sphere C, so then let's do the same thing for B to C. It's a 1 to 2 ratio where C is smaller. So it's 1 to 2, which means that would be 8 to 1, and that would be 4 to 1. Work out this ratio of the surface area of A to the surface area of C. So we're going to have to make the B's the same. So A, B, C would be, if we make these the same, that has to be 100 in the middle. We multiply this by 4 to get 64. We multiply this by 25 to get 25. And so the A to C ratio in surface area is 64 to 25. Done. So you'll see that one, the most important thing was recognizing which skill to use. Here, 2 cuboids. All the lengths are measured in centimeters. The volume of this is 142 greater than the volume of this. We can turn that into a mathematical formula. So the volume of this is x plus 2, x minus 1, 2x minus 1 is equal to 2x into x plus 3 into x minus 3. And it's 142 more than this one. Work out the value of x. Interesting. Right, well, this is going to be 2x into x squared minus 9, and then plus a 142. So it's a 2x cubed minus an 18x plus a 142. Oh, man, I was really hoping. Well, no, it will simplify. So here, this is x squared plus x minus 2 into 2x minus 1. Then you get 2x cubed. 2x squared minus an x squared is plus an x squared. Minus 4x minus x is minus 5x, and plus 2. That will cancel on both sides. Leave this where it is. So x squared, add 18. So plus 13x minus that minus 140 equals 0. I'm seeing 20 and 7. Yes. So x plus 20, x minus 7. So x is equal to minus 20, or x is equal to 7. But x has to be positive. So x is equal to 7. And that's the answer. Cool. X equals 7. Next, ABC is a triangle. Work out the length of AB. I'm seeing sine rule. So x over sine 45 equals 3 root 2 over sine 30. I can never be bothered to learn them. I will never apologize for that. 1, 2 root 3. So sine 30 is a half. So that's the same as multiplying by 2. So that's 6 root 2 over there. And this is sine 45. That's your 1 root 2. That's 1 over root 2, which makes that root 2. Lots of x. Cancel on both sides. X is equal to 6. Okay. Here, parallelogram. So, okay, we've got vectors. M is the point such that that's a third. Nope, it's a quarter. So 1 quarter, 3 quarter. And that is a third, and that's 2/3. And OZ, so it's 1/3 B, 2/3 B. OY is equal to A, so that's a quarter A, and that's 3/4 A. Work out the ratio of XN to MN, assuming that these are collinear. So XN, okay, so OX is OY, which is A, plus YX, which is the same as ZO, which is, so OX is equal to that. So XN is equal to B minus A, which is the negative of that, plus a third B, which is minus A and 4/3 B. MN is minus a quarter A plus a third B. So therefore, this is equal to 4 lots of MN. So it's a 4-to-1 ratio. Okay, rationalize this thing. So that's 15 root 5 over 5. Cancels, 3 root 5 at the end. This thing, so multiply top and bottom. Now we're getting into proper ESAT territory, by the way. This feels very ESAT because it's a simple skill, but you've got to execute it quickly. So on the bottom, I'm going to have 1 minus, now that would, so 1 minus 12, but on the top, we're going to have, I should really have simplified that first. So root 75 is 5 root 3. So that's going to be 5 root 3 minus 30 minus 2 plus 4 root 3. So I'm getting 9 root 3 minus 32 over minus 11, which is 32 minus 9 root 3 over 11. That's what I'm thinking. Although now we're getting to the point where I'm like, so especially this speed. So BCD is 40. That immediately means that this full angle here is 40. Angle OAB is 3. So that X is 3 times angle OAC. And so in other words, that's 30 and that's 10. I'll work out the size of ACD. Well, that's 30. So that's also 30 because that's a thingy, which means that is, so 60, there's 120 left. Center is double the angle, so that's 60, which is half of that. And so ACD is equal to 100. Done. Okay, so we've got a function, we got to invert. That's simple enough. We just say x equals 5y minus 3, having over 4, having swapped around the x and y. 4x equals 5y minus 3, 4x plus 3 plus 3. Come on, all over 5. Now, luckily, you won't have to deal with that in the real thing. 4x. And I'm also seeing here that doing it mentally is just not as fun and not in keeping with how you'll do the real thing. So this thing, g of h of 5. So h of 5 is 1 minus 10 is minus 9. Plug that into g. So g of minus 9 is equal to 100 because it's minus 9 minus 1 is minus 10. Square it for 100. Cool. Semifinals, player A will play player B. C will play D. 2 winners will play each other in the final. The probability that A wins against B is 0.6. Huh. Now I actually have to think. Why are you making me think? So the probability that A wins the chess tournament. So that's the probability of A beats. Okay. So I'm going to quickly draw a tree diagram. I think that's the easiest way of doing this. So A wins or B wins. So that's 0.6, that's 0.4. Now, if A wins, how am I going to do? Okay. No, I'm going to go back to my original way. So so that's the probability of A beats B and C, or it's A beats B and then D. So that A has to beat B, so that's 0.6, and C has to win, which is 0.2, and then A has to beat C, which is 0.5. Or A has to win, and D has to win, which is 0.8, and then A has to beat D, which is 0.3. So 0.5 makes that 0.1, makes that 0.06. This is 3/5 and 4/5 and 3/10. Nope, not going to do it that way. That's 0.6 times 0.24. So 0. Yeah, this is a part of my mental math which isn't the strongest, clearly. Carry the 2, so 144. Yeah, 6 times 24, 3 times 48, 12 times 12. Yeah, 144. And so at the 0.06 onto that, you get 0.204. I slowed down there. So we have this circle, find an equation of the tangent to the circle at this point, at the point P1. So P squared plus 1 equals 4, where P is bigger than 0. So P squared equals 3, so P equals root 3. So we have P. We have the gradient is equal to 1 over root 3, which is the change in y over the change in x from the center of the circle. Because remember, tangent and radius are 90 degrees. So the tangent, the radius gradient is change in y, which is 1 over change in x there. So the perpendicular gradient is minus root 3. So it's, and I'm going to use the A-level formula, y minus 1 is equal to minus root 3x minus root 3, and get it in this form. So that's minus root 3x plus 3. So y plus root 3x equals 4. Done. Total for paper is 80 marks, and that's time. Not bad. 18 and a half minutes-ish. So 18 minutes and 28. All right, let me go back through that and just sort of see how I felt. So I felt like I was obviously on top of it. I have to calm myself down. Well, I have to bring myself back into sort of normal speech patterns after I've kind of like blitzed. So yeah, things like this, simplifying, this is an important skill for your ESAT, understanding how to mathematically simplify things as quickly as possible. Factor redistribution is a skill. I'll do that as sort of, I see it. Nothing here stressed me out too much, except for, this part. There are little things when it comes to more complicated calculations that you would normally do on a calculator. Clearly, my mental math isn't strong enough that is a good. So that's the weakest part of my game, seemingly, just by my own analysis. So maybe if I'm doing process work sort of after the fact, I might do that. I might find I would say, hey, generative AI tool of my liking, generate me some, calculations like this. And you can just rep those over and over again. And just practice that skill in isolation so you feel like it's really strong when you need to use it in the real thing. I think that came up again where my mental math wasn't the strongest. I can't remember where it is. My algebra is good. Where did that happen? That I wasn't hugely confident on. There was somewhere else where I was like, it was here where I wasn't super confident on multiplying those together. But I'm glad that I got a GCSE paper done in under 20 minutes. So given that the amount of time is 90, I think that's not bad. And that's what you would do. So you've now put a time on the board. You would want to beat that time the next time you do it. Now, let's check on my accuracy. So I'll split this. Hold on, let me pause share for a bit, just so I can kind of lay these out. Zoom out of here. Zoom into the mark scheme. Readjust. Apologies, while I tech. Okay, so going back to sharing entire screen so we can get both at once. Here, let's see I didn't make any silly mistakes. Obviously, I'm not going through checking technique in this one because you have no time to check in the real thing. So here, 682, absolutely fine. 75, it'll be greater. 2 1/3, yeah. Shown, yes, I did. Here, yep, 180 minus 4e. I estimated 10. Minutes. Are we just not giving me an answer here, bud? What are we doing here? 1/6 of an hour is 10 minutes. All right. They don't seem to have an answer. Well, I'll just take it. And it's an overestimate. Good. Here, C is equal to 55. Here, it's the rate of change of volume, rate of flow out of tank. I'm even more precise, 4.5. Drawn the box plot. Yes, with supporting. 10, 1/8. They did it the other way around. Yep, yep. Good. This one was good. X equals 7. Perfect. X equals 6. 4:1 ratio. 3√5. Nailed that. Okay, that was my least confident solve in that. So I think I'm going to be fine now. It's 100. Yep. 100. Actually, this was my least confident, but I got that one right as well. So that was good. I kind of did a few double takes on that. Oh, ESAT is a lot easier than I thought. Even if I'm not applying to Oxbridge, should I do it because of how easy it is? If you don't need it, don't do it. There are other universities that do require it, though. So it's necessary for... Well, so bear in mind, this is not an ESAT paper. This is a GCSE paper. So I'm hoping you're doing that based on the actual ESAT that you've seen. So compare it not to this paper, but compare it to the NSAA or the ENGA papers that you may have seen in the past. So this is, yeah, not an ESAT paper, but it is how we will train the ESAT skill. Also bear in mind that the ESAT, it's used for... It may be required for other things. So if you're applying for engineering at Imperial, I know they require it for that. Like several Imperial courses require it, and you'll just need to check if your university requires it. But you're right. Now notice what you just said. Oh, it's easier than you thought. That's exactly what I said at the start here, is that you want to make sure that the math you're trying this on is very easy, so you can just focus on how you're doing it. So for me, I noticed from paying attention to my process, a lot of that was just all gas, no brakes, like, let's go for it. And I went through it in really good time. There were moments where I was like, oh, actually, I have to slow down on this bit. Oh, I have to sort of tiptoe through this. I'm not as confident here. And that's what I mean by the diagnostics. All of the focus is going not on the math that you're doing, but how you're doing it. Recognizing what the weakest part of your game is, and then finding ways to isolate that skill to improve it so it's stronger next time you need to use it. That's the aim of the game. So I'm going to go through the same process, but with the AS paper. Now, the AS paper is going to be harder. So that was all training for like the Math 1 stuff. So actually, no, let me go back. I want to give some commentary on what feels very ESAT in that. So out of that, let's kind of go through and give commentary on what I thought might be relevant. So this actually is surprisingly relevant because you get some quite complicated expressions. You need to simplify the numbers down, and getting good at that is a really important skill. So things like, so let's say, hello. So let's say we've got like factor redistribution we got to do. So let's say instead this was over 2.5. So it would be like 81 over 25. I could have multiplied top and bottom by 4, which would have made 100, which would have made it very easy to then simplify that. Other things you can do are, like I say, factor redistribution. If you're doing, for instance, 25 times 36, we can take a 4 from there, put it in there, and it becomes 100 times 9. And so it's just 900 very easily. Little tricks like that, super helpful. This, surprisingly relevant. It's a multi-step sort of process to arrive at the probability, and then working out a prediction based on that. So it's because it's a lot of steps in 90 seconds, this actually is quite relevant. These are utterly irrelevant. Again, not super relevant, not that relevant, not that relevant, but maybe something similar to it. This, they would have asked a much harder version, but this is in theory part of it. This is not relevant at all. No. Yes to B. Obviously, this is sort of included in harder parts of it. This is so ESAT. Especially Math 1, like that, the similar shapes in 3D, the length, area, volume idea, and especially combining different ratios. This question, very, very ESAT. So that's what I'm pleased I did. This is also very ESAT, where you have to like simplify the algebraic expressions and get them right quickly. ESAT here would have been a harder version of this, but what is very ESAT here is dealing with the 30 and the 45, understanding how to take sine, cos, and tan of those special values. I've got my resolving triangles on hand, my 30, 60, 90, my 45, 45, 90, so it means I'm never going to get lost there. So in that respect, that's quite ESAT. This is not very ESAT. This one here, like I commented on the time, this is very ESAT. So you'll notice it's what you should always do. Simplify as much as possible before you get into it. And then it makes your numbers just a lot easier to deal with. Get really good at this. Like I can guarantee this skill will come up. Factor or rationalizing denominators when there's a plus or a minus on the bottom. Super important skill. Not so relevant. Not so relevant. Very relevant. This felt very ESAT. In fact, like this would have made an exceptionally good ESAT question because it's the sort of thing where it's doable, but you kind of look at it and go like, how do I do this? So in the real thing, I would recommend that this would be like a second pass ESAT question. So the first pass are ones where you look at it, you're like, I know what I'm doing. I got this. And then second pass like this is where I'm like double taking and I'm thinking, how am I going to do this? Am I going to do the tree diagram or do it based on like sort of simple definitions of probability? For an ESAT perspective, that makes this a second pass. Do all your other questions first, then come back to a question like this. This also felt very ESAT. Only they would have given you, no, they might have done that circle. But yeah, mainly because it's multi-step. And you have to find the P, then you have to find the gradient, then the perpendicular gradient, and put it into a straight line and get none of it wrong. So that's what I think in terms of like the relevance to the ESAT Math 1. Right, so now let's pop over. In fact, I'm going to need to stop share just because I know with the AS paper that I'm about to do, I'll need to share the entire screen because I may need to bring the calculator across. I'm at peace with that outcome. So, screen 2. Math 2 time. All right, I won't be able to do it in 18 minutes, but in theory, because this is a 2-hour paper, but I wonder if my proportion would be the same. So given that I did it in 18 and a half minutes, so 18 and a half out of the 90, let's multiply that by the 120 minutes. So in theory, I should get this done in, if I go at exactly the same pace, I should get this done in under 25 minutes. Let's see if that happens. It's unlikely to, because obviously the GCSE content is easier than the AS content. But similarly, Math 1 content is easier than Math 2 content. So let's see how this, oh, and also I'll need to press buttons on calculators. So this will take longer, but I want to get it under, let's see how close to 25 minutes I can get this. Certainly under half an hour. Right, let's go. Okay, so here, that is the integral of 2. Now that would be x to the half minus 2x to the minus 3 over 2, 2x to that, minus 3x to the minus 2. We're going to integrate that, raise the power to minus a half, divide by that, so it becomes minus 4x to the minus a half, raise that to minus 1, plus 3x to the minus 1, plus c. Done. Give your answer in simplest form. I think that is. Unless they want it as minus 4 over root x, plus 3 over x, plus c. Let's belt and braces. Don't forget your plus c. Done. So question 2. Factor of this x minus 4. So factor theorem. So that means that f of 4 is 64 times that is 128 minus 16 is a 48a plus 4b plus 8a equals 0. So adding that across, 40a is 128 plus 4b divided by 4. We get 32 plus b is equal to 10a as given. Good. Given also that this is a factor, that means that f of 2, which is 16 minus 12a plus b plus 8a, is also equal to 0. So 16 plus b is equal to 4a. Subtract these two, 16 cancels equals 6a. Oh, I don't like that. Am I doing this wrong? Well, I know I got that right. So plug the 2 back in. So 16, 4 minus 12a. Sorry, that should have been 2b. Apologies. So 8 plus b equals 2a. That minus that. 32 minus 8, so 24. The b's cancel equals 8a. That's more like it. A is equal to 3. B, so that makes that 6. So b is equal to minus 2. So this thing is 2x cubed minus 9x squared minus 2x plus 24. And these are both factors, so I can take an x minus 4 out, and I'll get, no, in fact, I'll take the x minus 2 out. That'll be easier. So yeah, this is taking some time. X minus 2 into 2x squared. So minus 4x squared, I need another minus 5x squared. So that's plus 10, I need minus 12, and that tracks there. So it's x minus 2. I should get an x minus 4 out, and then I should be left with 2x plus 3. So k is equal to 3. Cool. Hence, state the number of real roots. There are 3 roots. Write down the largest root of that. That multiplies it by 3. So it would have been 2 or 4 or minus 3 over 2. The largest of that is therefore going to be 12. Done. So that's question 2 out the way. Question 3. I'm not sure this is there, but I'll do it anyway because I can. Find PQ. So to go from P to Q, I go minus 6 i's, and then I go plus 3 j's. Given that r is a point such that qr is equal to this, show that that is true. So we've got our qr, we've got our pq. I'm going to be really annoying and take the dot product because I can from further math. So pq dotted with qr is going to be equal to minus 54 plus 54 equals 0, therefore 90 degrees. Sorry about it if you don't know further math. Yeah, I'm going to go with it. Given also that S is the point where that is true, find the exact area of PQRS. This is a trapezium. So that's PS. QR. No, it's the other way around. So QR is the small one, so that's QR, for instance, and that's PS. Find the exact area. Well, that's the average of the parallel sides times the distance in between. So that would be the distance QP. And QP is that. So the magnitude of that is the root of 36 plus 9, which is the root of 45, which is 3 root 5. So that there is 3 root 5. The magnitude of QR is the root of, well, it's, in fact, I'll take a 9, that's equal to 9 into I plus 2j. So the I plus 2j, so that's 1, 2, that would be root 5. So that magnitude of that becomes 9 root 5. So the magnitude of this is 27 root 5. So the average of those is going to be 18 root 5. So it's 18 root 5 times 3 root 5, which is equal to 18 times 3 times 5. Take a factor redistribution. So that's 9 times 3 times 10. So it's 270. Taking a 2, putting it with the 5, done. Question 4. Given that ADC is a straight line, BD is x. Okay, so this is all given. Show that x equals 10.5 to 3 sig figs. This will require a calculator. This is fine. That angle there is going to be equal to 10. That angle there is going to be equal to 150. Show that. So we're going to sine rule this, presumably. Yes. So x over sine 30 equals x plus 3 all over sine 140. So I'm going to do this as much as possible without a calculator, only use it at the last step. Sine 30, again, my 30, 60, 90, 1, 2, root 3. Sine 30 opposite over adjacent, so that's going to be 2x equals x plus 3 over sine 140. So 2x times sine 140 is x plus 3. So x into 2 sine 140 minus 1 equals 3. So x is going to be equal to, I ruined my calculator. No. Okay, I'm going to have to reopen it, guys. Okay, I'll come back to it. No. Wasting seconds. This is why I'm really glad the ESAT does not have calculators. Silly tech. So it should be, run matrix, come on. So it's equal to 3 over 2. Am I in radians? I'm in degrees. 2 sine 140 minus 1, which is 10.51, so 10.5 as given. Great. Given also that AD is x minus 2. So find the length of AB. Right, well, that's going to be 505. I'm going to call it 505 to 3 sig figs. So I'm going to make it more accurate because you need more significant figures to stay accurate. So use more precision than you need moving forward. So this becomes 8.505. This becomes 13.505. AB is the square root of 8.505 squared, 13.505 squared, minus 2 times 8.505 times 13.505 times cos of 150. So in fact, I already have my answer here. So I'm going to use the answer to be completely precise in my calculator like I would in the real thing. So the square root of answer minus 2 squared plus answer plus 3 squared minus 2 answer minus 2 answer plus 3 cos 150 equals 21.3. Done. Okay, so that's question 4. Question 5. We have this curve. Sketch the curve where we're crossing the coordinate axes. That's going to be simple enough. So it's adding 3. So it does this, and it does this. And it crosses when x is equal to minus 2. Yep, state the equations of any asymptotes. So the asymptotes are going to be when x equals 0 and when y equals 3. We have this quadratic, show that they intersect when this thing, well, they intersect when they're equal. So this guy equals 6 over x plus 3. We can multiply through by x, so cubed minus 4x squared minus 10x equals 6 plus 3x. Move that across to make the minus 13, move the 6 across to make that, that's fine. Given that the x-coordinate of one of the points of intersection is this, well, this would have come from a root of 3x plus 2. Right, so you factorize that, that's 3x plus 2 into x squared plus 2x. So we need minus 6x's in total. So this is, I use an inspection method. So that's plus 2x, we need minus 6. So we need to minus 2x to make that minus 6x squared. That's minus 4x I need another minus 9x, so it's minus 3. So it's 3x plus 2, x minus 3, x plus 1. The x-coordinates of the other points of intersection are going to be x equals 3, x equals minus 1. Okay, that's question 5. Question 6, binomial expansion up to and including the term of this is that. Show this. So that's going to be 1 plus 12ax plus whatever the hell 12 choose 2 is. I'm going to non-calc that. So that's 12 factorial all over 10 factorial, 2 factorial. So that's 12 times 11 times 10 factorial. Cancels. All over 2. Cancels. That is equal to 66. So 66a squared x squared. So from here, we can see that 12a is equal to minus 15 over 2. So a is equal to minus 15 over 24. Cancel 3's, minus 5 over 8, done. Hence find k. K is equal to 16a squared. So it would be 16 times 25 over 64. Cancel a 2, 32, 33. I can't make a 4 come through there. Well, 32 of those would make 800. So it's 825 all over 32. Okay. Using the expansion, making it method clear. How would you do this? Well, so that would be 1 minus 5/8 x to the 12. In this case, 1 minus 5/8 x would equal 17. So 1 and a 16th. Cancels. Multiply both sides by 16. Sure. Minus 10x equals 1. X equals minus 0.1. Giving it, so you have to plug that in on this guy. So it becomes minus 15 over 2. So that's 1 minus 7.5x plus nonsense x squared. So that would be 1 plus 0.75. And now this I actually am going to have to do on the calculator times 0.01. So trying to use the calculator as little as humanly possible. So I keep on saying with my students, use the stairs. If you can do it without, do it without. Times 0.01. So that is this monster. So it's 1.75 plus 0.2578, so 4 dp. That becomes 2.0078, I think. So we'll see if I made any mistakes there. Here, find a complete equation of this form. What I always do here is, so I take logs of both sides of the model. So it's log A plus X log B. So log P and X. So the gradient, so that means that log A is the intercept is 3.3. So A is equal to 10 to the 3.3. We also know that log B is equal to the gradient. The change in Y is minus 1.2 all over the change in X of that, which is minus 12 over 60, which is minus a fifth, which is minus 0.2. So B is equal to 10 to the minus 0.2. You can plug those in and get it. With reference to the model, interpret the value of A, B. That's when X is equal to 1. So that is that's the parts per million at X is equal to 1 at 1 kilometer from chimney. Okay. Here we have a cubic, we have a tangent. Show using calculus that the coordinates of A, given that, show using calculus Right, so we know that the gradient is -2, so differentiate this, we get 3x squared minus 14, and that's going to be equal to -2. So 3x squared is equal to 12, x squared equals 4, x is equal to 2 because a is it's positive. Okay, so the line cuts C again at the point B. Verify, it only says verify. The x coordinate of B is that. So let's plug -4 into there. So that would give us y is equal to 15, plugging it into there. And then plugging it into here, we would get -64 plus 56 plus 23. So knocking 50 off both of those, so that would be -8. So that is equal to 15. So yes, they intersect. It works. The finite region is bounded by that. Use algebraic integration. Show that the area is 108. So that is, I'm going to do that. I'm going to choose to do this as the integral of curve minus line. You can also do that as integral minus the area of the trapezium. So I'm going to say it's the integral between -4 and 2 of x cubed, what is it? It's x cubed minus 14x plus 23. Subtract off from that the this line here. So subtracting off there becomes plus 2x minus 7. So that turns this, so it's between -2 and 2 of x cubed minus 12x plus 16. So raise this, so that becomes 1/4 x to the 4 minus 6x squared plus 16x between 2 and -4. Plugging in the 2, we would get 16 over 4 is 4. That becomes 4, so minus 24 plus 32. And we'd subtract off from that. So 16, 2, 5, 6. Well, one of the 4s will cancel, so it would be 64. 16 times 6 is 96. So minus 96 minus 64. Those will cancel. So it is that minus that is 8. So it's 12 plus 96, which is equal to 108. Done. Okay. Question 9. So we've got our logs. Find in terms of P and B. This is so good. Well, that is equal to the log to base A of 16 squared. So it's 2 log A of 16, which is equal to 2P. That is equal to the log. This is log A of 4 times 25. So it's the log A of 4 plus the log A of 25. So that's the log A of, that's 16 to a half. So it becomes a half P plus Q. Now this guy here, I'm seeing that becomes, because no, because it's tempting to bring those together, but no, that would be if the logs were added. So instead, this is going to be, that is 16 times 5. So that's going to be log of 16 times, and 5 is 25 to the half, multiplied by, now that is, so 3.2 is 32 over 10 is 16 over 5. So that's times the log of 16 times 25 to the minus a half. In other words, that is P plus a half Q multiplied by P minus a half Q, which is p squared minus a quarter q squared, because that's the difference of two squares. Love that question. Here we go. So we've got a circle. The point Q lies on the circle. K is a positive constant. The line is tangent. That, given that the gradient of line L is 2, well, as we saw before, if that means that gradient is equal to a half because they're perpendicular. And the gradient between those guys is going to be k squared minus 2k minus k minus 8, which is the change in y, all over the change in x, which is 4. And that gradient is going to be equal to a half. So multiplying both sides by 4, we're going to get k squared minus 3k minus 8 is equal to 2. K squared minus 3k minus 10 equals 0. Done. Hence find. So we're going to factorize that. K minus 5, k plus 2 equals 0. So k is equal to 5, or k is equal to minus 2. Let's look at this for a second. K is a positive constant, so therefore k has to be equal to 5. So hence find an equation for C. Well, the center is P is good. So the center of the circle, so the center is -1 and 13, it looks like. And the radius will be the distance between P and Q. So that is P, which is 1 minus 1, 13. And Q is going to be 3. And 25 minus 10 is 15. Because then, and let me just check. So that is very much a half. So the difference there, so the distance to the radius is the root of 4 squared and 2 squared, which is root of 16, and 4 is root 20, is 2 root 5. Well, actually, r squared is therefore 20. So therefore, it is x plus 1 squared and y minus 13 squared is equal to 20 is the equation of C. 11. So prices of two precious metals. So we have this thing. Price per gram is modeled as this thing. So that's price per gram of A, which is the months. Price per gram of B is given by that. Given that VB when t equals 0. So when t equals 0, that's once, that's P. So that means that P is equal to twice. Now when that's 0, that's equal to 120. So it's equal to 240 is the value of P. When t equals C, the rate of increase in the price per gram of A. So that change, so that will go to 0, is going to be equal to 20 times 0.04. Move a 10 across, 10 times 2 is equal to 0.8 e to the 0.04 t. Was equal to the rate of decrease. So the rate of decrease here is, again, minus 0.02 times 240. Again, let's move a 10, 0.2 times 24. So that's 2 times 2.4 is 4.8. So that is minus 4.8 e to the minus 0.02 t. So that's decrease. So the rate of increase is equal to the rate of decrease of that. Find the value of t. So that is when 0.8 e to the 0.04 t will equal 4.8 e to the minus 0.02 t. So if we divide by 0.8 on both sides, we get 6. If we divide both sides by, or multiply both sides by e to the 0.02 t, we get e to the 0.06 t equals 6. 0.06 t is equal to ln 6. T is equal to ln 6 all over 0.06. And I won't bother putting that in. But it just would be the answer. So here, I have literally seen optimization questions like this on the ESAT, by the way. Given that the quarter circle has radius x, rectangles are x and y, show that the perimeter of the pool is given by that. So the perimeter of the pool, well, the total surface area of the pool. So let's start there because that's the thing we don't want. So the area of the pool is a quarter pi x squared plus 2xy. which is equal to 100. From that, we can solve for y. So y is equal to 100 minus 1/4 pi x squared all over 2x. Now the perimeter is equal to 1, 2, 3, 4 y's, 2 x's, and 1/4 of the circumference, and the circumference is 2 pi r plus 1/4 of 2 pi times the rate x. So that, in other words, it's pi x over 2. And 4y is going to be 200 minus 1/2 pi x squared all over x plus 2x plus pi x over 2. So it's 200 over x minus 1/2 pi x plus 1/2 pi x will cancel. So plus 2x. So it's, yeah, this thing, 2x plus 200 over x, done. Use calculus to find the value of p stationary points. So differentiate set to 0. So we differentiate, we get 2 minus 200 over x squared would equal 0. So 200 over x squared equals 2. 100 over x squared equals 1. 100 equals x squared. X equals 10 because it has to be positive. Prove that this value gives a minimum. Differentiate again. We get 200 over x cubed, which is 200 over 1,000, which is 0.2, which is bigger than 0, therefore minimum. Access to the pool is by side AB is shown. Good evening, good evening. It's by side AB. Given that AB must be, so AB is y. So the pool with minimum perimeter is, again, when x is equal to 10. When x is equal to 10, y is equal to 100 minus 25 pi all over 20, which equals 5 minus 5/4 pi. I actually will need to find out what side of 1 that is. Let's approximate, actually. 5 minus, let's call that 3, 15 over 4. So that seems legit. So it seems like it should be fine. Let me confirm that it's fine, though. No, stop it. So 5 minus 1.25, where's pi? There it is. Yes. It's actually equal to 1.0 something something. So it's bigger than 1. That's a better word. Um, 13. Trig things show that this equation can be written like that. This feels very ESAT. So here we have 7 sine squared. I'll write S and C just to save some seconds. So minus 4 SC equals 4. Let's divide through by cos squared. So that means that 7 sine squared all over cos squared minus 4 sine over cos equals 4. And this would become sec squared. Now, sine squared plus cos squared equals 1. So tan squared plus 1 equals sec squared. So therefore, 7 tan squared minus 4 tan equals 4 into tan squared plus 1. So it's 4 tan squared plus 4. So 3 tan squared minus 4 tan minus 4 equals 0 as given. Hence solve. Does that factorize? So minus 12. So it's minus 6 plus 2. Yeah. So 3t and t minus 6 plus 2. So tan is equal to minus 2/3, or tan is equal to 2. This is not very ESAT, so I'm actually not going to bother doing it, but it would be what happens when you solve for those. Actually, no, I will bother doing it just to make sure I've got the other values as well. Whoop. Oh dear. That was perfectly done. Let me just find the 0 again and the execute button. Okay. So inverse tan. Again, you got to make judgment calls when you're doing speed work. So this would give x is so 63.4. And 180 plus that, I can do that without. So 180 added onto that is 243.4. Now let's do the minus 2/3. So inverse tan of minus 2/3. No, nah. Fighting with the tech would be that. Plus 180 on that. Let me try and do that mentally. So that would be 147.3. And add another 180 to that. I'm going to get 327.3. Okay. Hence, find the smallest solution of this equation. What's the difference here? X is equal to 4 alpha. So 4 alpha equals x. Oh, that's disgusting. Let's find the smallest solution in this range. So alpha equals x over 4. Let's find the smallest solution. So what's 4 times 720? So 4 times 720 is 1440 times 2 is 2880 is less than x is less than something I don't care about. So what's the, and I have to add 180s to these until I get something over that. Now adding 180, so this is close. That would have been a 0 point. That's a 0 point plus 4 lots of 180. So that, like, I have to find the smallest. So it would be this. I think much more than that. So it would be 2880 plus 63.4 all over 4, which is the 720 from before, plus, let me see if I can do this. 1, carry 2, 5, carry the 3, 8, 5 is 735.9. I hate that. That was bad. Did not enjoy. And finally, prove this is even. Hello, I'm nearly done with the paper and then I'll get right to you. So prove that this is even for all n. So n even, this is not very ESAT, but I'm going to do it anyway. So if n is equal to 2k, then n squared plus 5n is 4k squared plus 10k, which we can take a 2 out of. Therefore, it's even. And for n odd, where n is equal to 2k plus 1, then n squared plus 5n is, well, I'll rewrite that. So that would be 4k squared plus 4k plus 1, plus 5 lots of that is 10k plus 1. So it's 4k squared plus 14k plus 2, where again, I can take a 2 out of that and get 2k squared and 7k and 1. So therefore, that's also even because we can take a 2 out of it. So it's even for all n, and that's time. So a little off my target. So that was about 36 minutes. But again, there was a lot of faffing there with calculators. We have a common question. So you're an international student enrolled in the IB program, which means you're unfamiliar with the content of Math 1 and Math 2. What do you suggest for reviewing the topics? Excellent question. You're not alone in that, by the way. I have someone else who, in fact, it might be you, Totally fine if it is, but I've spoken to someone else recently who was in a similar situation where they were behind on the math. If this seems to be a thing across the board, if this is a problem for IB students gaining access to the ESAT, I can do a specific deep dive on it. If you need me to teach you. So for him, for instance, it was calculus, I think. It was differentiation and integration. Or maybe he was fine with differentiation, but it was the integration he hadn't learned yet. If there's something like that, feel free to drop a suggestion. I can do a deep dive. Alternatively, you have resources like Save My Exams. You have all your IB resources, your revision village, which you might get ahead on. You can look at the spec and it goes line by line through everything you need to know. There are plenty of resources for the A level. So something like, what's it called? Let me have a look. So there's an A level maths exam questions by topic. We'll give you worksheets to practice all of these skills. Yeah, do you have I'm happy to hear from you. Do you have do you know specifically what topics you have in mind? Because I can easily do like a sort of deep dive on that. And if you join on that session, you can like be in the chat and we can basically do this as if it's like a legit tutoring session. Because if it's useful for you, it'll be useful for other IB people, right? It won't be just you. So now on this one, let me pause for a second. Let me get this thing split out. I didn't mean to do that. Hold on. What did I mean to do? I meant to do that. Please pause while I tech. Okay. In fact, let me not do it like that. Let me kind of, yeah. So going back to here, sharing the entire screen so I can get both. Let me scroll back to the top here. And I'll kind of give commentary as I go. This is very ESAT. Asking you to perform integrals, top ESAT skill, definitely need to know how to do this. Let me see which form the mark scheme wanted. Probability statistics and geometry, which are covered in Math 1, are not included in Math IB. Remember that Math 1 is the equivalent of UK GCSE, though, which is pre-IB, I suppose. While calculus, which is covered in Math 2, is taught in the final year. Yes, the differentiation and integration is going to be a big one. So I think I might do an entire calculus differentiation and integration stream then, because you are not alone in that bucket. Okay, so here, minus 4x to the minus a half plus 3x minus 1 plus c is correct. Good. So here I was doing a whole bunch of nonsense, but let me just make sure my nonsense was correct. So here we got it. K is equal to 3. Yes, it is. 3 and 12. Good. Also, as you're here, this is the chat here, not permanent. If you go to the Discord server, I'm going to be much more likely to retain that. So if you, the link for that is in the description of this video. If you want to pop that in streaming suggestions, it maximizes my chances of not forgetting. So I highly recommend that. So here, P to Q is this. Good. Now I used further math techniques. What did they do? So they probably showed it uses obeys Pythagoras. Or they got the gradients and showed they were perpendicular. That's fine as well. I knew further math, so I used further math, and I'm not sorry about it. And you get to do that, by the way. If you have skills to hand, use them. Because ESAT is fast. So whatever your fastest skill is at your educational level, go for it. Just because it's not on the spec does not mean you can't use it if it is relevant to the problem. And then C, 270, boom. No, I'm proud of myself for getting that without using the calculator. So use the stairs, guys. even if you could use a calculator, choose not to get yourself better at the mental math. So here, I've lost where I am. Is this 4? Yeah, 4. So 10.5 is given. 21.3, good. Sketching, good. -2, good. Asymptotes, good. Show that. I showed that. Find the others. 3 minus 1, good. That's the this is very ESAT, the remainder theorem and factorizing and stuff like that. So making sure that is a good skill for you. Binomial is in here, but definitely C is not the skill. But I still got it, only using the calculator for one small part at the end there. But the rest of it was on all non-calc and was correct, which is good. This doesn't feel especially ESAT to me. Mainly because I couldn't be bothered to work out the numbers. And that's why. It's because you don't have calculators, so you can't do that bit. But it's the concentration, it's the parts per million at 1 kilometer from the chimney. That is good. Show, I showed it. Verify, I verified it. Show, I showed it. Good. I really liked 9. They could easily do something like 9 in the ESAT. So 2p, a half p plus q. Yeah, p squared minus a quarter. This was fun. I really liked 9. Oh, and this is also rather ESAT. Maybe a variant on this, but you see lots of these coordinate geometry questions involving circles and tangents. So let me check this. I got it. K was 5. And so this thing in 20. Good. While we're here, I want to point out one thing. So if you were asked to find, for instance, let's say instead that P was on the y-axis and you wanted to work out the area of this triangle, a lot of people would be tempted, because this is a right angle, to work out that distance and then do half base times height on that. But in fact, it's much easier to get the change in y and the change in x as your base and height, respectively. So coordinate geometry, when you have intersecting lines and an axis, that is how to work out the area if they're perpendicular. Not from the legs sort of that are perpendicular, but from this base, which is the change in the difference in the y-intercepts, and the height, which is the x value of the intercept of these two lines. Probabilities, stats, and calculus. Sure, I could do that. In fact, I'll drop that now in the Discord server. So probability. What was it? It was probability statistics and calculus, right? That is in streaming suggestions to remind me to get that done. So yeah, just that reminder about coordinate geometry and other problems that are common for ESAT. 11A, so 240. Let me just check that this would have given me the right answer. So no. Ln 6 all over 0.06 is 29.86. 29.9, which is correct. So I did get it correct, which I'm quite pleased with. And P was 240. So all of this was correct. 12. I found that. X is 10. Oh, I differentiated wrong. Why did I differentiate wrong? Apologies. Okay, so this was my first little execution error because I went too quickly. What I should really have done here is to say that it's minus 200 x to the minus 2. So that should have differentiated to 400 x to the minus 3, not 200 x to the minus 3. So apologies. The second derivative was 0.4, which is bigger than 0, hence minimum. So apologies for that. But you plug in, you get a value of y, which is bigger than 1, so that's fine. Trig is fun, so that was simple enough. Solve it. Now, this was difficult without... Oh, boom. 735.9 is exactly what I got. And this is just so not ESAT. It's not worth going into, but I solved it great. Okay. So what I'll do now is, like I did before, I'll get rid of the mark scheme. Let's go just back through the AS paper and see what was relevant and what was not. So for ESAT, what would I expect to come up that would be super relevant? Differentiation and integration like this, standard integrals, polynomials, very much expect that to come up. This, again, a form of this. These skills are very ESAT. Factor theorem, finding other factors. Notice, by the way, in fact, let's have this conversation. So one thing you can do to get really quick is to get good at factorizing by inspection instead of needing to do algebraic long division. I think there are other forms of algebraic division that exist. My preference is inspection. So what I saw here was once I had my cubic, I had an x minus 2 to take out. In order to form the 2x cubed, I needed 2x squared. That would leave me with minus 4x squared, but I have minus 9x squared, so I need another minus 5x squared, which I get from this x, and minus 5x that I put there. And then that would give me plus 10x, but I need minus 2x, so I need minus 12x, which I get from doing x, and minus 12. And then I confirm that those two multiply to 24, which they do. So that inspection method saves me some valuable seconds. And then factorizing this is not too bad, especially when given that x minus 4 is already a factor. So same thing, you needed 2x to make the x squared. This would give you minus 8, so we needed a plus 3x to bring it to minus 5. And then the minus 4 times 3 does give you minus 12. So practice doing that. Practice factorizing cubics by inspection, given remainder theorem, given factor theorem. Stating the number of real roots, very ESAT. Largest real root of a transformed, very ESAT. So this entire question, very, very ESAT. This one, not so ESAT. I'm not sure they give you as many vector things like this, but they could very easily. So part C they could do in a different form, but this idea of having surds like this and needing to work out the area of the trapezium, that is super ESAT. And you'll notice what I did was I very easily found the average of those two as being 18 root 5, multiplying them together. And that trick here of factor redistribution for non-calculator is priceless for saving you some valuable seconds. So as soon as I saw a 5, I saw that I could take a factor of 2 from that, put it onto there to make it 9 and 10, which is then just 27 times 10. So factor redistribution for ease of non-calculator skills. This, in the form given, is very much not ESAT, but I have seen things involving the cosine rule in a different form. So some of these skills in isolation are ESAT, but this question as given, not so much, especially this whole calculator business at the end. This, I could easily see a form of this that could be ESAT, but they would need to obviously massively redo it. But again, this using inspection to find the other things. So once I had this cubic, and we knew that 3x plus 2 was a factor, I knew I needed an x squared to make my 3x cubed, sorry. That would leave me with 2x squareds to start with, but I need minus 4x squareds. So I need to subtract 6x squareds. So from there, I need a minus 2x to multiply with the 3x to give me that minus 6x squared that I need. Then similarly, I have minus 4x from that, but I need minus 13x. So I need to subtract another 9x, which means multiplying a minus 3 by this 3x to get there. It's just a faster form of that algebraic long division, but you would have got there from algebraic long division as long as you don't make mistakes. From there, factorizing as usual. That is quite ESAT. This A and B could easily have been ESAT, C not so much. You do see binomial in ESAT math too. So just making sure you're okay with that, especially your Pascal's triangle, or let's have a look at, sometimes you might need to use this. Actually, I'll check that. I'm not entirely convinced of that, but you're just your friendly reminder that NCR is n factorial all over n minus r factorial times r factorial. So choose 2, it becomes very easy because like you see here, that's 12 times 11 times 10 factorial, which cancels down. And then, yeah, it's not too bad from there. Always take the stairs. Yes, you could have done 12 choose 2 on a calculator. Decide not to. Work those mental math muscles. Here, not very ESAT. This is very ESAT. For getting that 108, that very, very ESAT. The numbers as well were super doable without a calculator. Like, this could easily have come up. So get good at this kind of thing. This could be quite ESAT, especially sort of C. I could totally see C coming up in an ESAT. And again, we've spoken about this. Yes to the coordinate geometry, uses of circles and tangents, and finding areas of triangles, and all this kind of thing. Maybe not the question is specifically given. But yeah, this totally could have come up. Like all that kind of stuff. Circles, coordinate geometry, yes. This, less so as given, because of the use of calculator in the exponential. This I have totally seen an optimization problem, asking you to maximize the area. So stuff like this, get very used to how this works. When I do my calculus deep dive, this is one of the things I'm going to lean into, but this is what is called an optimization problem. So you have 2 equations, perimeter and area, and 2 variables. You make the unwanted variable the subject of the unwanted formula, in this case making y the subject of the area when we want perimeter in terms of x. So once we get our y, we sub into the perimeter and simplify. Once we have the perimeter in terms of x, you differentiate, set to 0, and that gives you your max or min value as required. And yes, I have seen that come up on an ESAT, and yes, they did expect you to do it in 90 seconds. So getting really good at that is highly recommended. Also, trig. They love trig. They don't ask you necessarily to find the answers to one decimal place, but they could ask you, for instance, about the number of solutions, or if the numbers were a bit better, then they could ask you to solve. And I would not necessarily expect something like C, although they could do whatever they want, let's be honest. And then this would not come up at all. So I think that gives you a sense of how I would do some speed training, right? It practices your brain's ability to jump between different topics while working at maximum speed. And you can get, by paying attention to what you're doing, you can get a sense of where your weaknesses are. So I found those 2 places in my mental math which weren't the strongest, which you can then target those skills specifically. Also, by marking your work, you can see if you made any execution errors at speed that you wouldn't make at normal pace, like I did when taking that double differential where I forgot that it was x to the minus 2, so I had to do 200 times the minus 2 to turn it into a 400. That kind of thing. Where, given that the ESAT is multiple choice, and they predict the types of execution error they expect to see, and purposely plant those wrong answers somewhere in your multiple choice, it's really important you have strong execution at the sort of race pace that's required of you. So yeah, that's what I would do. So carrying on with your sort of syllabus work, building up the sort of strength on the conceptual stuff that you need to, while also doing some of this stuff, that's speed training. So yeah, doing those in parallel. So I'm glad I've got these 2 out the way to kind of show you how to go about your training process. This is what I recommend for all of my students. And this is very much what I recommend you to do as well. And we can kind of gamify it. So maybe down the line, I could do GCSE papers with my hands on my head where I just sort of say the answers out loud. Like, you guys can set me challenges. We can have some fun with it. You guys can kind of like create a little culture where you're kind of congratulating each other and kind of pushing each other on like how quickly you can do different papers. So that was my time. I got a sort of 18 and a half minutes, I think it was, for the math the GCSE math, and this one was 36 minutes for an AS paper. What I can do is I can sort of keep going with this. Like, can I beat my own personal bests? I wouldn't be too concerned about like, oh, I have to get to a specific objective goal or else I'm not going to make it. It's more about the process, right? It's more about making, because remember, what's our target here? The target is so that when you go to the ESAT on the day, you know that your skills are able to handle what's coming. So it doesn't matter if you weren't able to get to sub 20 minutes on a GCSE paper. The only thing that matters is your confidence and capacity on the day of the ESAT. So given that this is not your direct target, the AS paper or the or the GCSE papers, it's more about the process. It's more about how you feel about your strength and your speed and everything to do with that. So it's your kind of training dojo for you to just build up that speed and confidence. And that's what I want you guys to take away from this today. So with that, unless there are any other questions, I think I'm going to leave you to your sunny, hot Thursday evening. So thanks for the suggestions. I'll do that on my next topic stream. We'll do a bit of an educational deep dive on any of the topics you guys need me to cover conceptually. And then in my live solves, I'll probably do a bit more of this, some speed work. Maybe if you guys want me to do a bit more like generative AI, like how to use that to like target specific skills. You guys obviously have your like worksheets available. You have your textbooks available. So hopefully you guys are good enough to kind of like handle that on your own. But if you guys have any interesting ideas of what you want to see in terms of like techniques that you might use in your revision that you want me to demonstrate, feel free to drop those in comments or in the Discord server, and I'm happy to take a look. Right. I'm going to leave it there. Thank you very much, guys. In fact, let me bring you over here so I can say goodbye face to face. I will see you guys when I see you. My schedules are very flexible over the summer. Things keep coming up. People are kind of coming in for ad hoc sessions. So unfortunately, I don't have a nice regular slot. Although I might aim for Monday mornings because that looks okay for now. But when I do have a regular slot, you'll be the first to know. So in the meantime, keep posted. I will always make sure to populate my streams well in advance on YouTube. I also always put sort of announcements in Discord if that's where you prefer to get your notifications. Do the YouTube things if you want to sort of stay sort of in the loop with what we're doing here. And I will see you guys next week. Hopefully, probably on Monday. But if not, then you'll find out. All right, take care, guys. Have a good rest of your evening. Bye-bye.